All right. All right. Hello, everybody, and welcome to the stream. Today is November 6th, 2019. It's about 12:02 in the afternoon, so just a hair late. Let's get to it. Today, we're going to get back to work on the whole predicting dog sounds thing. I have built a model. Hooray. And I have a Raspberry Pi. We're going to connect to the Raspberry Pi. We're going to set up the Raspberry Pi so that it can pick up the sound in real time. And then it can make a prediction. We're going to do all of this on my local machine first, and then we're going to switch it over to the Raspberry Pi. I'm going to plug in my my headset, and then we'll see if we can make it do the thing. And that's the plan for today. Once we get this done, the only thing that I have left to do for this whole dog mood prediction thing I've been working on is to basically do the write-up and get the model as accurate as I possibly can. Right now, when I'm testing it, it gets to about 75% accuracy on the training data. Have not tested it on the validation set yet, so you probably want to do that as well. And that's it. I'd like to give a couple of shout-outs. First off, WorldWig, thank you so much for the Tier 1 subscription. I know I thanked you last week when it happened, but thank you again. I really, really appreciate that. I'd also like to thank MD3XT3R. Thank you for the follow. And Mustafa Al-Hayali, thank you again for the follow. All right, let's go ahead and get to it. First things first. All right, here's our repo. So I have this model trained over here. We're going to figure out how to load that up because I don't honestly know. But that's what we're going to do. We're going to figure out how to load it up. And then we're going to have this thing model run. Let's talk about model run. All right, the way this works is you can first run it and it'll show you all the audio devices. Let's go ahead and do that actually. So let's go to, and this isn't going to work. I have to pull up Anaconda. All right. Adding featured channels. Loading applications. Man, who knows what that's doing to my computer? It just seems really heavyweight. Like that's my only issue with Anaconda. It's like anything that's running like 900 scripts when it loads up and it's not like one application. It's just weird. All right, so we want to go to I. We want to go to Content Lab, Dog Bark, code dot. All right, what doing that did was actually change the version of Python that I'm using here. And now we're on the Python for the actual version here, which is what I was trying to get done. Okay, great. Now what do we want to do? All right, we want to take a look at it. So we have Python model run. And what it's doing right now, is recording my voice, and when I stop it, we can go play it. Oh. Uh-oh. Oh, press enter to stop. Okay, so what that did was it just recorded this thing called recording.wave. I guess we're going to have to go to the browser. File. Content Lab, Dog Bark. It recorded this file called recording.wave. And what it's doing right now, is recording my voice, and when I stop it, we can go play it. Uh-oh. Oh. Uh-oh. Anyway, and what it's doing right now... Alright, so that's what it does. It records my voice to a WAV file. what we can do is we can say list, and this will... That's interesting. Not what I expected. Let's go take a look at why we're getting an error here. That's the train. I want the run. Device count. I think what we probably want to do is actually have this load up Let's just do this as a real for loop. Okay, we're gonna say audio.get get device info by index of I. And then what we're going to do here is we're going to say info. And then what we're going to do here is we're going to say info inputs dot append info. And then we're going to comment this out for a moment just to take a look at what it's going to spit out. Yeah, that's right. It's in one of these. Okay, and then what I wanted to do was say print inputs. And then the idea being that I care to look at, there's an index okay, I think we just go like this then. We'll just use this one instead of this host API index. So this has the max input channels. That's what I'm looking for. That's how you know it's it has the ability to record. So let's go back, and basically we want this. And then instead of this, we want this. Okay. And then we want to say list. Okay. Now we got no error. So great. So that's what we wanted to do, and this is only microphones. You'll see microphone, microphone, it's a microphone. This is the sound mapper input, microphone, 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 stereo input, microphone, 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 microphone. Yeah, that's right. Okay, so this is it, and this is the one that is set up as the default device for the machine. This is, if you don't specify it when you run it, that's the one that it's going to use. So when you just run this, it's going to use the one that's marked as default right there. And that's sort of what we're looking for. That's what list devices is. If you want to tell it to use another one specifically, you just put a space. Oops. You just down here put a space and then put the number next to it. And that will choose the correct one for you. Okay. So now what we do is we want to listen, right? When this thing runs, it's going to fire off this listen. It's going to grab the device index, either the one that was passed in, or it's going to go and get the default, which is great. And then we're setting the output to be this WAV file, and we're saying to prepare this WAV file. Okay, then we're saying go ahead and open the stream, start the stream. Like this says take control of that device. This says start the recording. And then you wait until the person presses enter, then you stop the stream, and then you close it and you move on. Make sure you close everything out before you exit. Okay, so this is like the vast majority of the work. And what we want to do is we want to clean this up a bit. So right now it creates Pi Audio. And then this is just a thing to choose what we want to do. This is a listen default, which is the normal one. And then after the very end, we say terminate the audio, which releases all of the whatever. Now, basically this stuff right here that handles all of the recording, like all of this stuff, I want to extract into another tool. And I want that tool to be sort of replaceable so that this thing right here will start the stream. And this says prepare an audio file, prepare output audio file. And this says make record callback. It's this make record callback that I want to replace. Basically, what I want to put here instead is a function that sends the captured audio off to whoever wants it. And that's sort of the plan. So let's go ahead and do that. So we're going to want output audio. Listener save wave file. And I think I actually want this to be listener save wave .py. So the way that this is going to work is we're going to have basically going to just move all of this in here. And then this is going to move in here. And then this make record callback is actually going to be something else. Okay. And I want this stream callback to now instead be def forward audio data. All right, and this callback has to have a specific one of these, like this. And then basically what I want to do is just say something like listeners equals array. And then in here, I just want to say for each for listener in listeners listener dot handle or I don't know, some function name to say, like, you know, process. All right, now this in data, okay, how do I want to do this? All right, you just get the data. That's it, you just get the data. Just the raw data. And then from here we need to return the in data and this magic thing. All right, so we're going to have some listeners. A listener is basically going to be a function. That's right. And we're going to have listener save wave. So here we're just going to have output file name. Okay. Class. Listener wave save. Def init. Self pass. Okay. Self dot file name. Let's go file name equals file name, because I don't actually want this in here. And then I want def handle. So it needs to be a class with a function called handle that takes in audio data. Pass. Let's go ahead and put this in here. We're going to say import listener wave save. And in the handler, in the listeners, we're going to have listener wave save dot listen wave save and recording up dot wave. Okay. And let's go yeah, we're just going to append onto it, I guess. No, we're not. But we're going to do it like this. Self.output wave file. File name. Prepare. equals prepare output file. Okay. And then this actually needs to have some audio properties passed into it. So we need, all right, we need the device information. Audio device index. Okay. If we go back and look at here, I want to actually print the device info. Print device info. And this is going to be totally broken at the moment. Why? Because there's no callback. I guess that doesn't really matter. We want forward audio data. Okay. And then listeners, we're just going to comment this out for now. And so ideally what happens here is I just want to see what self. We don't need this. Come back to that. Okay, so output file dot close. All right. Okay, so these listeners are going to have to okay. All right, what we got was the input channels, the default sample rate. What was the other thing that we needed? We needed the sample width. So we're just going to have a class called audio properties. Device info dot name. Okay. And then here we're going to have audio properties. And this is going to be sample width. And then we're going to have sample rate, device, default sample rate, and then we're going to have channels. And I think we're just going to go with 1 on this, and we can come back to that if we need to. I think we're going to, let's go device max input channels. Okay, so that gets the audio properties. Let's do format. pyaudio.pa-int16. Channels is audio property channels, audio properties of sample rate, input true, frames per buffer. This is the more interesting one. So far what I've been doing is making it so that it just triggers that it just triggers whenever this happens. I think I'm going to stick with this. So basically this makes it so that we only get a message once every second. Okay, and so now I need to do initialize listeners, to do start listeners, and then to do stop listeners. Okay. And I need this to be I guess we just make this a class. Okay, let's make this a class. Listener device. Class listener device. Def init self pass. And then what we actually want to put in here is this. Is there like a deconstructor in Python? That's my next question. Deconstructor. Del self. That's what I want. Def. Is this Python 2 or Python 3? Python 3. For if you see any difference in Python 3, June 12th, 2009. How do I... Okay. Del will even be called when a init has not been executed properly or thrown an exception. Python 3 patterns. There you go. Cleanup. Del. Yeah. Okay. Without an explicit call to del, del is only called at the end of the program. That's fine. Not this. Self. Okay. Self.audio.terminate. Okay. Now we have list devices. Boom. We don't need audio in here anymore because we can say self.audio. Maybe we just say audio equals self.audio. Okay. And then here, okay. Okay, what we want to do is say device equals listener device. Device.list devices. Device.listen. Device.listen. Then we don't need that anymore. Okay, this should be self audio equals self.audio. And then we want self dot forward audio data. And then we want self dot listeners okay. And then in here we have self.listeners because we go self. I think we actually want to like underscore that one. I believe that's like the way that you tell things that it should be. Okay. I think that works. Okay, we still got the listen. Oh. Listen. Missing one required positional on 79. We need to get rid of audio. Okay. Sample width is not defined. Okay, I think what we need to do is Python map literal. Oh, you have to quote them. Got it. That's super interesting. Listener device is not subscriptable on line 79. Device. Oh, device info. Well, that's interesting. I'm not actually putting the index in here, am I? Okay, pyaudio.open. Pyaudio open. I want to open a specific device. Open. Parameters. Input device index. That's what I want. Equals device info index. Index. Okay. Okay, so that's going to open the one we specify. Frames per buffer. I think we want 1 there. Frames specifies the number of frames per buffer. I think we want 1. Frames per buffer. Okay. I'm going to put frames per buffer equals 1. That's my plan. Or maybe we just don't use that at all. Okay, let's just try not using it at all. Now we want add listener. Def add listener self listener. This dot listeners dot append. Nope, self dot listeners dot append listener. Yay. Okay. So now what we want to do is say that a listener what do we want? We want a listener device. Okay. Import Pi audio. Okay. We don't need wave. We don't need Pi audio. We need import listener device. From listener device, import listener device. Okay. We need sys. We don't need time. Okay. Then here, okay, let's just see if this works. Just to make sure that we have it in the correct place. Okay, that works. Good stuff. And then let's see if this works. No. Pi audio. Model run 15, listener device 49. 49. It's not device info anymore, is it? Yes, it is device info. It's this open that's failing. Integer argument expected got float. For which one? Okay, let's print device info. Oh, default sample rate. Oh, sure. Okay, yeah, that's fine. Okay. And then down here, I want to say print frame count. Oh, that's not going to work. Oh, okay. Sure. Frame frames. Okay, audio.open. Frames per buffer. Frames per buffer. I'm going to guess that that equals that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Okay, that's perfect. Frame count. Len of in data. That's quite large. Okay, so I'm guessing, I'm like kicking wires down here. I'm guessing what's about to happen is that this is 2 channels at 44 samples, and the width is 2. So if we change this to 1 and just manually put it at 1, and then the sample size and then we have a sample size here, which is, let's just print it out. Okay, yeah, the sample width is 2, the frame rate, and the channels. So basically you take these 3 numbers, you multiply them together, and that's what your expected size of this should be. So what we want to do is basically convert this we want to convert the data as it comes in directly to what it should be. Okay. I wonder if we can, if we look at like the size. What do we want to do? We want to convert. Okay, so I'm guessing that this is okay. So type of in data. If I had to guess that this is bytes, and I probably okay, it is bytes. So somehow I want to convert that to an array of 16-bit. Okay. Python array of bytes to, what are we trying to change it to? Array of int 16. I don't want an int, I want an array. Python doesn't traditionally have much use for numbers in big Indian C layout that are too big for C. If you're dealing with 2-byte, 4-byte, or 8-byte numbers, that's not helpful. Interpret strings as packed binary data. Unpack the string, presumably packed by the given format. NumPy. Here are some hexint. Byte array. HH contains two parts. One, the greater than indicates binary data is big Indian, or in other words, the data is ordered. Okay. HH means there are two objects of H types. H represents unsigned short. I'm not sure here. NumPy.fromBuffer. I don't have a problem with that. Okay. Okay. Import NumPy as np. how did that work? np.from buffer type self.device.info self.audio properties. Okay. Now what I want to do is self dot. Okay, data equals np dot from buffer np dot from buffer d type equals np dot okay. Now then, I guess the question is, what is it supposed to be? And the way that we would figure that out is we would come up here and we would say something like train sample rate num seconds random uniform okay, so it's an int okay, it's an int 16 np.int 16. Okay, we can do that. You pass the buffer in, you say the type, you say the count. Okay. Okay. In data, d type equals np.int16 and count equals frame count. Okay, let's see how that works. Device info not defined. Okay. On line 41. Okay. All right. It's still coming out as bytes. Oh, because I didn't do this. All right, and there we go. All right. So we have now converted it to, and just for the sake of argument, let's just do the old print data. Just so we can be sure. Okay. And this time I'm gonna be loud as it goes so that I can sort of see it jumping. I want to see the numbers be more extreme. So if I start talking really loud, you see that the numbers get higher. And when I talk really quiet, they're much smaller. All right, we're actually getting what we expected here. And we also see that they get very, very high up into the tens of thousands. What if they get into the tens of thousands? Okay, there we go. That was pretty cool. Sorry for yelling in your ear. But what we were able to verify is that we are correctly converting them to different values. And then this is the data that we want to pass on. Yeah, I'm sorry about that. I do feel good about actually getting through that part of it, though. That's kind of frustrating. Okay. Oops. Spilling water everywhere. Okay, so now what we have is the data correctly formatted, and now all we have to do is create each of the listeners. Now for this, I think we're just going to have a for listener in listeners in self dot listeners listener dot initialize, which really I guess we already did that when we created them. So we're not going to have initialize. I think instead what we'll have is here for listener in self.listeners listener dot start. And I want to have this start and stop, so it's basically telling it to like close whatever file or whatever, release whatever you had. That's it. That's my plan. Okay, so we should be done with listener device. Now we should come in here and we should actually look at the listener. Okay, so we have this one. It needs to have three functions. It needs to have handle, def start, self pass, handle, self pass. I'll probably put this one up here. def stop self pass. Those are what I said. All right, we have listener start stop and process. Okay. Okay, great. What do you want to do on start? On start, we want to create the file. We want to open the file. On stop, we want to close the file. Self.output file equals self.prepare self.file name. And then we want to say close the file. Output self.output file.close. In process. Okay, and then this is okay. This needs to be audio properties self dot. Let's put it at the end here. Actually, I think it needs to be the first thing. Okay. Audio properties, because everything's going to have access to the audio properties. Self dot audio properties equals audio properties. And then I had this whole function. And then I don't even need this. And I think I just want to do this. File. File. Nope. Yeah, okay, output file. Okay, import wave. Okay. Channels equals self.audio property dot channels. Sample rate sample width, sample rate. Okay. Self.output file equals output file. Okay, that takes care of that. We don't need this anymore. And then here we want self.output file.write frames. And I don't need any of this anymore. And I don't need this anymore. Okay, listener wave save. So now we can come in here and we can say device. We can say device dot add listener, and we can say listener device import listener wave save. I can say listener wave save. Oh. Maybe that's where I need to initialize things. Because I got to get the audio properties in there. Okay. So I think this right here is actually something we want to do beforehand. I want to, before I create the device, I want to get, okay. So we're just gonna move this up. We're gonna say device ID index equals int args1 if else none. And then we're going to say device equals listen device of device index. And here, we're just going to say else listen. Okay. So now we need to change this listener device to take in the index self.index self.device index. Okay. So in here, now we don't need this because we have the device info. Actually, I think we're just going to move all of this. Okay. And then we can come down here and we can drop this. So at the beginning we're saying, all right, print out the device index, get the audio properties all up front. Now I can pass the audio properties into the other things at the time that I am initializing them. Right on. Okay, and so I can say device dot audio properties, listener wave save, audio properties, and recording dot wave. Okay, audio properties passed in. All right, let's see if it does it. Deleted recording. Let's see if we can still list. No. Fun. Self.audio. Okay, we got our list. It's printing the device info. Let's just print the whole thing. Name is self.deviceinfo of name. And then I can skip printing this one. And I think if I put the index in here, I don't actually need this one either. List devices definitely needs all of that jazz. Alright, yeah, this one we can just put the index in here. So let's just put the index in here. And at this point, I don't actually need the device info anymore. Index. Okay. And that lets us clean this up. Okay. Just for the sake of argument. Okay, yeah, they're all in here. Alright, I think that's going to do it. Audio is not defined. I feel kind of dumb here because I am basically just copying all of the values out of here with the exception that I want to change channels to 1. Yeah, whatever. Yeah, whatever. Okay. Alright, I got only the stuff that I care about. Let's go selected. Audio device. Perfect. And now let's do it one more time where it actually tries to record. Output file name on line 9. On line 9. Oh, it's self.file name. And, oh, in data, it's audio data. It should be recording me at this moment. Let's see if it's recording me. Come on, one time. It should be recording me at this moment. Let's see if it's It should be recording me at this moment. Let's see if it's It should be recording me. So that's super interesting. Because we're using a sort of a large buffer size here, and we only get the data once a second, if you turn it off too early, it closes the file before the recording sends it. But for the purposes of what we're doing here, that doesn't really matter. This is really just a demo. That is interesting, though. I don't want this to happen very quickly either. I want the processing, because we're running this on a Raspberry Pi, I want the processing to have that delay. Okay. So now the fun part. That's saving it to a WAV file. Now we're going to create listener dog mood detector. Listener dog mood detector.py. And this should basically be copying all of this and putting it in here. And then not calling it this, but calling it dog listener dog mood detector. Yep. And we want the same thing, only in this case we're not going to have the file name. We're going to have model path. Equals model path. And then I probably don't really want anything in here. And I probably don't want anything in here. And then this basically needs to say okay, convert input data to VGG-ish parameters, embedding. That would be more correct. And then pass embedding to model output prediction. Okay. So that's what we need to do. First things first. Let's get this going. Inference demo. So what this does, demonstrate how the various building blocks, feature extraction, model definition, and loading post-processing work together in an inference context. A WAV file assumed to contain 16-bit PCM samples, which is exactly what we just got, is read in, converted into logmel blah blah blah, fed into VGG-ish, and the raw embedding output is whitened and quantized, And the post-processed embeddings are optionally written in a sequence, example, whatever. We're not going to do that part. All right, so this is all the stuff that we need. And now this is generating data. Examples batch. Wave file to examples. Okay. Wave file. Okay, so we need to take the wave data, divide it by this, and then call waveform to examples, where we pass in the data, the sample rate. Okay. We're going to copy as much of this as we possibly can because I don't like changing other people's work when I can avoid it. So we need mel features, VGG-ish params, sound file as SF. Okay, we don't need that. I am going to cut out as much of this as possible. So we're just going to move as much of this to the bottom as we can. Okay. Mel features. I don't want all of this polluting my stuff. Okay. So we're going to say mel features input params. Mel features input params. Copy. And basically paste them down here. Okay. Import, and for this one we want input VGG-ish, import VGG-ish input. We say VGG-ish input dot waveform to examples. Okay, audio data equals audio data divided by, and this is the other one we need, which is inference demo. Okay, this input is waveform to examples of audio data divided by this, and self.audio properties sample rate. Okay. VGG input samples. I really just want to call it sample. Okay. That gives us the input to VGG-ish. What's the thing that calls? Okay. We need VGG as post process. Okay, we need the post processor, which just needs the params. Okay, so copy, paste. Okay. And I think this is actually something that we can load up one time. PCA params. Path to the params file. There they are. Okay. Post process. And then I think we just pass this in here. Okay. And then we have, okay, so I don't need that anymore. And then in here, we don't need this writer because that's not what we're going to do with it. So we have a graph and we have a session. Okay, define so we're going to need 2 graphs and 2 sessions. Okay. We don't actually need any of that. All right, def generate embedding self audio data. Embedding equals self dot generate embedding of audio data. Okay. So I want to tell it to load. I want to tell it here to load this model. What do I need? What do I need a hold of? Embedding tensor. Okay, examples batch. So basically, I want to load all of this. I don't care about the print statements. All right, I want to preload all of this. This checkpoint is VGG-ish model, VGG-ish model dot CKPT. VGG-ish. Okay. Okay, self dot VGG graph equals, okay, import TensorFlow. As TF dot graph self dot VGG sesh equals TF dot session graph equals self dot VGG graph. Okay, VGG slim. So I need VGG slim. Do I need the params? Yes, I do. import VGG params, post process, and slim. Input params post process slim. Okay. Params post process slim. There's those. This one. So now I need slim. Okay. Post process. I need slim. I need slim. And what does slim need? Nothing. Paste. Okay. Define where is this session? Okay. VGG is slim load checkpoint. Okay, this one right here. Okay, and then self.features tensor, self.this. That's kind of a lot. And then I guess for the sake of argument, we just want to print embedding. Okay. Okay. Self.embedding tensor, self.features tensor. And then self.pproc, and then just return post-process batch. That is kind of a lot to have happen here. But if we did it correctly, it should spit out a bunch of... It should spit out stuff. Okay, wow, that was kind of a lot. I have like a 3% chance of this working successfully on the first try. It seems to be recording, but it's not actually adding anything out here. So that's a little frustrating. Okay. I also did not see... Oh, because I didn't load up the dog mood. Okay, duh. Okay. Let's go to model run. And for this one, we now want to have not this. We want from listener dog mood detector import listener dog mood detector. Okay, and I don't actually want this one anymore. I want this one. Device dot audio properties, and then I want the model path, which is just dot, or maybe we just have that be none by default. Model path equals none, because I wasn't actually using it anyway. And then here I want to say there's some sort of like path.combine or something. Python path.combine. Join. Okay, os.path.joins. Import os. os Python. I just want to make sure it's not going to fail if I pass in none. os.path.join d thing.zip. Okay. None. Type error. It does fail. What if I do? Okay, I can just... Okay. I guess I don't even really care about model path. I care that if model path is none. Actually, why would I even want to? Well, I do, because you can pass in none. No. Yeah, let's just make it an empty string. As hard as that seems to be. os.path.combine, no, .join. Of model path. Okay. os.path.join model path. That is one last time. All right, still 0% chance it's going to work. The session graph is empty. Add operations to the graph before calling run. Well, that's interesting. It failed on in restore. Content lab dog bark. VGG slim. Checkpoint path. Is VGG-ish underscore model CKPT. Okay. $277 megabytes. I'm going to go ahead and say that file's not empty. Okay. that's going to be it for now. I have to take a break because I have a call in 1 minute at 2 o'clock. Thank you, everybody, for hanging out today. I will be back tomorrow at noon. Probably going to be working on something else because I'm really tired of this project, even though I'm almost done with it. So I think I'm going to grind away on it tonight. And then tomorrow we'll probably get back to the... what was the other thing we were doing? It was the Markov decision... No. Monte Carlo tree search. Thanks for joining, and I'll see you later. Thanks.